This is 4.1 Systems of Equations. We are going to look at systems of two equations and look at different ways of solving them. We're going to solve by graphing, by substitution, and then two algebraic methods by substitution and by elimination. Okay, so to solve by graphing, what it means to solve it is to find the values of x and y that make both equations true. There are an infinite number of solutions to y equals x minus 4, an infinite number of solutions to y equals negative x plus 8, and we're looking for those values of x and y that make them both true. If we want to solve by graphing, that unique solution is the point of intersection. So the ordered pair is where they intersect. Okay, and this will be good to continue us on with a review of graphing as well. All right, if I start with y equals x minus 4, if it's in slope-intercept form, that's how I'm going to graph it. That means I begin at negative 4 on the y-axis. My slope is 1, so I go up 1, over 1, up 1, over 1, and so on and so forth. I want to graph as accurately as possible because what I'm looking for here is the point of intersection. Of course, draw my line through the points, put arrows on the end since it goes on forever and ever. If I have y equals negative x plus 8, I begin at 8. My slope is negative 1, so I go down 1 over 1. I happen to know that I end up over here at 8. And if I want to connect my dots, then the point of intersection here, which is 6, 2, this is my solution, the point 6, 2. That means when x is 6 and y is 2, it makes both of these equations true. Now, the other thing I want you to notice just in the big picture kind of thing is that notice that these two lines have different slopes. If the slopes are different, there will be exactly one solution. If the slopes are different, the lines will intersect somewhere, somehow. And then if we look up here at our vocabulary, exactly one solution means they are consistent. This set of systems is consistent and independent. Okay, 3x plus 3y equals 18 and negative 2x plus y equals negative 6. Now, these are not in slope-intercept form, so there are a couple things that you can do. You can put them in slope-intercept form, or you can use what I call the cover-up method, which means you can find the x and y intercepts. For this one, if I have 3x equals 18, I know that x is 6. If I know 3y is equal to 18, I know that y is 6. So that tells me my x-intercept is 6, 0. My y-intercept is 0, 6. So 0, 6, 6, 0, and that gives me my first line. If I do the same thing to my next one, if I have negative 2x equals negative 3, then x equals negative 3 over negative 2, which means x is 3 halves. Whoops. And I have that y equals negative 3. So my x-intercept is 3 halves, 0, and my y-intercept is 0, negative 3. Now, if I'm really good at graphing, I can graph that. If I'm not really good at graphing, 3 halves is 1.5, there's 1. Then I may want to do something else. I may want to pick another point and see what I can do with it. Or put it in slope-intercept form. Okay. So if I graph these 2 points, connect them with a line, then what I will have here is my solution, which is the 0.33. So again, this is consistent and independent. Okay, now we'll refer back to the vocabulary in a minute here as we do the 2 on the back. Okay, this next one, if I have 3x minus y or plus y equals 8 and 9x plus 3y equals 24, I can tell by looking at these that these are not going to have nice x-intercepts. So to graph it, I think I'm going to go ahead and put these in slope-intercept form. So this one, of course, all I have to do is subtract 3 from both sides, or subtract 3x, and I get y equals negative 3x plus 8. So that means I start at 8, go down 3 and over 1, go down 3 and over 1. And there's my line. If I do the second one, if I take this, I'm going to subtract 9x from both sides. So I get 3y is equal to negative 9x plus 24. Divide everything by 3, and I get y is negative 3x plus 8. So if you will notice here, both equations represent the same line. So everything on this line is a solution to both equations. So there are infinite solutions. And if I look back on the front, it says if there is more than one solution, this is consistent and dependent. Okay, my last one for graphing here, again, I think I'll go ahead and solve for y. So this one, if I subtract 2x from both sides, I get negative y is equal to negative 2x plus 5. I either multiply or divide by negative 1, and I get y equals 2x minus 5. Okay, so I start at negative 5, go up to over 1, up to over 1, and I can connect my dots. For my second equation, the first thing I'm going to do is add 6x to both sides. So I get 3y is equal to 6x plus 18. When I divide everything by 3, I get y equals 2x plus 6. So 6 up to over 1, up to over 1. And when I graph my lines, I can see if I've graphed this fairly accurately, what I see here is that the lines are parallel. But I also notice on here that these equations have the same the equations have the same slope, but different y-intercepts. so the lines are parallel. And of course, parallel means they never intersect, meaning there is no point of intersection. So no solution. And if I look back on my vocabulary, this means that the systems are inconsistent. Okay, let's look now at two different algebraic ways of doing this. The first one is substitution. The name tells it all. We're going to take something that is equivalent, like if I have $1 or I have 10 dimes. They are equivalent, but they just look different, but they represent the same thing. And substitute one into the other. Okay, so you will notice on this one that if I have this system here, y equals 3x plus 2 and x plus 2y is 11, I know what y is equal to, which means I can replace this for y, okay, which is exactly what I do here. And then I have an equation with only one variable in it, and I can solve that. So if I replace the y with its equivalent 3x plus 2, then I get x plus 2 times x plus 2 is 11, do my distribution, combine my like terms, subtract 4 from both sides. Here I combine the x and the 6x to get 7x. Subtract 4 from both sides, and I get 7x equals 7. Divide both sides by 7, and I get x equals 1. All right, now that I know what x is, I can substitute it in for x in one of the equations and solve for y. So I use this equation here because if I put x in here, I know automatically what y is, and substitute it for x. So y is 3 times 1 plus 2, which is 5. So the solution is 1, 5. So let's try a couple of these. Okay, x plus y is 7, y equals x plus 3. Okay, so this tells me right here, I know what y is. So I can replace x with that. So this equation is going to become x plus, and instead of y, x plus 3 equals 7. From here, I can add these equations together. I have 1x and 1x gives me 2x plus 3 is equal to 7. Subtract 3. I get 2x is equal to 4. Divide by 2, and I get that x is 2. So there's part of my solution. Okay. Well, now I'm going to take my equation y equals x plus 3, and if I know what x is, I can now plug it in for x. So I get that y is equal to 2 plus 3, which tells me that y is equal to 5. So I can write it as those solutions, or I can write it as an ordered pair of 2, 5. Okay, if I have x equals y plus 1 and x plus 2y is equal to 4, same thing. I know what x is equivalent to, so I can replace it in the other equation. And this gives me y plus 1 plus 2y is equal to 4. Y plus 2y gives me 3y plus 1 is 4. Subtract 1, 3y is 3. Divide by 3, and I get y is 1. All right, I'm going to go back and use the equation x equals y plus 1. I know what y is, so I can put it in here. I get that x is equal to 1 plus 1, so x is equal to 2. And I get my solution as 2, 1. It doesn't matter which order you solve in, you just need to make sure if you're writing it as an ordered pair that the x goes first and the y goes second. Okay, solving by elimination. This one's a little bit more complicated, but one of the rules of math that we need to remember is, and we know this already, is that anything plus its opposite is equal to 0. So we can say it is eliminated. So if I have 6 plus negative 6, that equals 0. If I have 3y plus negative 3y, that also equals 0. Anything plus its opposite is 0. Okay. So if I want to use the elimination method, a lot of times you're going to be given equations in standard form, and it may not be convenient to put it in slope-intercept form. You can solve for one variable and use substitution, but let's try elimination on this one. Okay, so here I have two systems. If I add these two equations, if I add the x's, the y's, and the constants, nothing will be eliminated. I'll have 2x plus 5y equals negative 15, which is perfectly valid, but it doesn't help. But if I want to, let's say I want to eliminate the x's. If I multiply this equation by negative 1, that would give me a negative 1x here, a positive 1x here. So if I in fact do that, that gives me negative x minus y minus 3y equals 7, and x plus 2y equals negative 8. Okay, so what that means here is that if I add these two together, this equals 0. And all I'm left with is negative 3 plus 2, which is negative 1y, equals negative 1. And so y equals 1. Since I know what y is, I can plug it into one of the equations and solve for x. I chose this one. It doesn't matter. So x plus 3 equals negative 7, and x equals negative 10. So my solution is negative 10, 1. All right, so let's do a few of these. If I want to solve using elimination, the first thing I want to do is look and see, well, if I add the equations together the way they are, will anything be eliminated? Well, in fact, yes, it will. So if I have 3x plus negative 3x, if I just add these together the way they are, this becomes 0, this becomes negative 3y, and this becomes 21. When I divide by negative 3, I get y equals negative 7. Then I'll pick an equation. It doesn't matter which one. I think I'll just choose this one. If I have 3x minus 6y is equal to 9, well, I know what y is, so I can plug that in here. So that gives me 3x minus 6 times negative 7 is equal to 9. 3x plus 42 is 9. if I subtract 42 from both sides, I get that 3x is equal to negative 33. And finally, I get that x is equal to negative 11. So my solution is negative 11, negative 7. Okay, for the next problem, 3x minus 2y equals 19 and 5x plus 4y equals 6. Again, if I add them together the way they are, it's perfectly legitimate, but what I get is 8x plus 2y equals 25, and that doesn't help me any. But what I do notice here, remember, I want some coefficient and its opposite. So if I wanted to eliminate the x's, I would have to multiply by 5 and 3, but I notice that 4 is a multiple of 2, and the signs are already opposite. So what I'm going to do here, I am going to multiply this top equation here by 2. So this equation becomes 6x minus 4y equals 38. And I didn't do anything to this one, so this becomes 5x plus 4y is equal to 6. Okay. So when I add these together, I get 11x, this becomes 0, and this becomes 44. When I divide by 11, I get that x is 4. Okay, so now I'm going to select one of the equations. It doesn't make much difference here. If I know 5x plus 4y is equal to 6, and I know that x is equal to 4, then I have 5 times 4 plus 4y is equal to 6. 20 plus 4y is 6. When I subtract 20 from both sides, it's negative 16, so y is negative 4. Oops, except this is negative 14. So this is negative 14 over 4, which is negative 7 over 2. Goodness gracious. Okay. So y is negative 7 over 2, and I can write my solution as 4 negative 7 over 2. Okay, a couple of more examples and then we shall be done. 0.2x minus 0.3y equals 1 and 3x minus 2y equals negative 2. Okay. Now, I'm trying to come up with a number for each of these is going to be difficult since I've got decimals. So the first thing I'm going to do is just get rid of the decimals. Okay. So if I want to get rid of the decimals, if I multiply times 10 moves the decimal one place right. If I multiply by 100, it moves it two places right. Okay, and so on. Okay. So I think this would be easier for me to work with if, in fact, I get rid of the decimal. So I'm going to multiply by 10. So this becomes 2x minus 3y is equal to 10. And I haven't done anything to this equation yet, so I'm going to write this as 3x minus 2y is equal to negative 2. From here, we have to make a decision. What is it do we want to eliminate? It's 6 and 1/2 dozen of another. The signs are the same, so I know I'm going to have to multiply one by a negative, one by a positive. I think I'll just go with the x's on this one. So what that means is I'm going to multiply the top equation times 3, the bottom equation times 2, and one of them needs to be negative. So I'll just make this one at the top negative. So this becomes negative 6x plus 9y is equal to negative 30, and this becomes negative 6x, positive 6x minus 4y is equal to negative 4. So if I add these together, this is eliminated, and I'm left with 5y is equal to negative 34. So y is negative 34 over 5. Not surprising when you've got decimals in your original problem. What I'm going to do here now is, since it's divisible by 5, it's easy to convert to a decimal, so this is negative 6.8. Okay, so let's bring down this equation. It doesn't matter really. If I have 3x minus 2y is equal to negative 2, since I know what y is equal to, I can place it in here. So I have 3x minus 2 times negative 6.8 is equal to negative 2. So 3x, a negative times a negative is a positive. 13.6 is negative 2. Subtract from both sides, I get 3x is negative 15.6. And when I divide by 3, I get finally that x is negative 5.2. And again, if I want to write it as an ordered pair, it's negative 5.2, negative 6.8. Okay, 2x minus 4y equals 12, 6x minus 12y equals 12. All right, let's see what happens. Let's see, I think I'll eliminate the x's. That means I am going to multiply this top equation by negative 3. That would give me negative 6x and a positive 6x. So negative 6x plus 12y is equal to negative 36. I didn't do anything to this one. So this becomes 6x minus 12y is equal to 12. So if I add these together, that is eliminated and that is eliminated. So I have 0 equals negative 24. Okay. This is never true. If you end up with a statement that is never true, that means there is no solution. Now, if you think you've made a goof or you think, well, why is that so? To check, put both equations in slope-intercept form. They should have the same slope and different E-R-E-N-T, different y-intercepts. Okay, finally our last equation here is 5x minus 2y equals 10, negative 10x plus 4y equals negative 20. Okay, same thing. I think I want to get rid of the x, so I'm going to multiply by negative 2. So that becomes negative 10, positive 2, I'm sorry. positive 10x minus 4y equals negative 20. I didn't do anything to this one, so this is negative 10x plus 4y, and this is a positive 20. Oh my goodness gracious, I should just start over. Okay, so what happens here when I add them? This is eliminated, and this is eliminated. So what I have is 0, 0 equals 0. This is always true. So there are infinite solutions. Okay, to check, put both equations in slope-intercept form, and they should be the same equation. Okay, so that's our introduction to graphing, elimination, substitution, and then 4.2 we're going to do something else.